Alright guys, we are working on 6.2, which is piecewise functions, and today we're finally getting to 6.2a, which is evaluating the piecewise function graphically and algebraically, and 6.2b, which is writing the equation of piecewise functions. We have done both of these in the previous videos in the introduction to piecewise functions. You are going to need a couple things. You're definitely going to need your... So
make sure you have that. I'm also going to make sure that you can pause this now to copy down our first example. Okay, let's do this again for our second example. And let's do this one more time for our third example down here. And make sure that you copy these graphs as closely as you possibly can. That way your notes will match up with my notes and all the numbers will make sense. Alright, so first let's take care of A, which is evaluate graphically, which says off a graph, and algebraically, which says using algebra. So if we have a graph, it looks like this piecewise graph has three different pieces. We've got a horizontal piece from -2 to the left. We've got a, so less than -2. We've got an interval from -2 is less than or equal to x is less than or equal to 0 for our domain. For this slanted up portion, this linear portion, it looks like our last portion is now a quadratic. It's making that U shape, which we did back in Unit 4. And I can do that by saying, straight lines are definitely linear, so that's a straight line, and that's a straight line, so these are linear. And then I can go over my quadratic one and say, quadratic, looks like a U. That looks like a U. Fantastic, I'm going to use x squared. So when you need to write the equations, all we're doing is evaluating them. It says, I want to know if I have an input of 0, what's my output according to this function? So remember that domain is your input functions and range is your output. So if I say an input for f of 0, I'm looking at the input of 0, my output is just 4. It's wherever that graph ends up. If I have an input of -2, I go to my input values of -2. I go to my output value for this piecewise, which is -2. It meets at both this coming down part and this going over part, and they intersect, which is very fortunate for us. Find f of 2. Our input value is 2. Our output value doesn't go up and down at all, so 0. And then last one, input value of -3. So we go back to -3. Output value is at 2 as well. So it's okay if we, actually, I'm sorry, I did this backwards. Our input of -2, our output should be +2, not -2. Some of you guys are going to say something about it, and that's good. Okay, so input value, output value. Evaluating graphically, super easy. Look at the graph, find out what your input is, tell me what the output is. No big deal. Okay, example 2. Given f of x, which is this stuff, we've got our equations, we've got our domain limiters over here. Evaluate algebraically. So here's the hard part about this. We're given our function, which is 2x plus 3 for 1 is less than or equal to x. So it says that x is bigger than or equal to 1. So everything, if we were to graph it over here, everything to the right would be where this function works. To the left side, so from everything where x is, that's supposed to be the other way around. X is less than 1. Good catch, Mr. Seaman. Everything x is less than 1. So if this is 1 is less than or equal to x, it says x is 1 that way. This is 1 is less than x, so everything the other way is going to have x squared minus 1 as the equation we're going to use. So f of 3. Well, the first thing we have to figure out is which domain is this equation going to be under. So if we say f of 3, is that bigger than 1 or is it less than 1? Well, it looks like to me that 3 is bigger than 1, so we're going to use our first equation. So we're going to do 2 of x is going to be replaced by 3 plus 3, which gives us 2 times 3 is 6 plus 3, which says that f of 3 is ultimately equal to 9. Alright, not too bad. Okay, let's look at f of 0. Again, we've got to check out for our input value, for our domain, which equation is governed by f of 0. So this is 0 is definitely not bigger than 1, which says that 0 is less than 1, which says we're going to use the second equation. So we're going to say f of 0 is 0 squared, replace the x, minus 1, which gives us 0 minus 1, which says f of 0 is ultimately equal to -1. I should box in my final answers to make this a little easier for you guys to see. We just evaluated algebraically, just like we did when we were making our packets, or just like we've done with the order operations in the past. The hard part is making sure you figure out which domain is the input which domain equation are we going to use? So remember, this is everything less than 1, and this is everything greater than 1. And then, like the problems I give you, I might switch up the problems, but it's still going to stay the same. We're still going to have our domains over here. You pick the right equation, and you just evaluate it. Okay, part 3, and this is probably the hardest part, which is why I'm only giving you a few practice problems for these. Write the equation of the piecewise function. So if you look up here at this one, we had 2 different pieces because there were 2 different independent styles of graph. When I look at my graph down here, I also have 2 pieces. So I'm going to use this as kind of a model. So I'm going to say f of x is equal to, and you could use whatever variable you want or whatever function names. You can call it g or h or t or r or whatever it is. We like to use consonants for some reason, whatever. And then we're going to have an open bracket saying we've got multiple parts to it under different domains. So maybe the easiest thing to do first is to figure out our domains. So it looks like for the one on the left, we always start least to greatest, just like when you're writing domains, is going to start at negative infinity and go all the way up to 1. So we can say for x is less than or equal to 1. And then it says the second one starts at 1, so we can say for x is greater than or equal to, because they're both closed circle there, equal to 1. And now the hard part is just writing our output. So if I look over here, I'm looking at my parent functions. It looks like to me this one's a linear parent function. It's just a straight line going all the way across at positive 4, which says if we think about it, our vertex usually is at 0, 0. It's going to go up to positive 4. We're going to have no slope on there. And remember that when we have our linear function, we've got our slope times x minus h and then plus k. So we have no slope, which says we've got 0 times anything which gives us 0. And more than that, we know that no matter what we evaluate this at, we're always going to get 4 as our output. So we can just say 4 is the output value, because it doesn't matter if we're finding f of 1, we're going to get 4. F of 0 is 4. F of negative 1 is 4. And all these numbers are less than 1, so they'll all work. So this works for our output. Okay, so it looks like the second part is, let's go back to this. It's not a V. It's quadratic again. It makes a nice U shape. And more than that, our parent function goes over 1 and up 1, over 1 and up 1, over 2 and up 4, over 2 and up 4, which says over 2 up 4, over 2 up 4, which says this is good. So we really, remember we have an a value which can stretch it, x minus h squared plus k. It's got that squared because we've got a squared right there. And remember, our h goes left and right, our k goes up and down, and our a is a stretch. We don't have a stretch because it's following the same exact parent function as this has right here. So instead, we just need to move our vertex, looks like to the right. So we're moving it 1, 2, 3 units to the right. So that says we're on the inside of parentheses. We're going to have x minus 1, 2, 3, because remember, right on the inside is negative. And then we're squared because we have a quadratic. This is what tells us the shape. And that's it. It's not shifted up or down. It's just moved right. So this is the written form of the parent of the piecewise function. We've got 4 for when x is less than or equal to 1, and x minus 3 quantities squared for when x is greater than or equal to 1. And see how this arrow keeps going at the end? All right, so we evaluated things graphically using a graph. We evaluated things algebraically by plugging it in. And the hard part is writing the equations. And I'm more than happy to help you with any of these. Let's get your practice worksheet and let's get started.